HAZLOC installation in dust atmospheres. In this presentation, we're going to be looking at Zone 20 dust environments 21 and 22. Dust environments are often more hazardous than gas atmospheres, and this is due to the mistaken belief by many workers in the areas that little danger exists. In a dust explosion, typically what happens first is a very small ignition or fire, and that stirs up air movement. Air movement then causes dust to start being airborne and accumulate in the atmosphere, at which point it then ignites against the initial flame and causes a migrating blast. Sadly, this occurred twice in 2012 in the province of BC. The first was at the Babine Forest Products sawmill in Burns Lake, BC, where we had 2 fatalities and 20 injuries. Sawmills are rife with dust in all sorts of different locations, and there is significant amounts of electrical devices in these situations. What we can see from the technical safety report that was made after the explosion is that they centered where the explosion likely came from, and it was an MCC room. You can see the scale of destruction that took place throughout the facility. It was determined that this MCC room here was the initial location of the explosion, and the room itself was torn to bits. And we can see here an example of how much sawdust was left on top of cables inside that particular area. There was a significant layer of sawdust left on top. And so that sort of speaks to the challenge or problem with this particular electrical installation. Now, generally speaking, what happened in this system and what happens in many systems in sawmills is that the MCCs are not explosion rated or dust rated. Instead, they're built into a room that is positively pressurized with a fresh air supply. And that means that under normal circumstances, this room has a slightly higher pressure than the adjoining rooms. That means that you need to ensure that the doors to the room remain shut and that the pressure system, as in the HVAC system, intake, the blower motor, all of that remains operational. Now, in the statement here, it says, employees stated that the pressurization system did not work as intended and was therefore not in use. The motor switch on the appliance was found in the on position while the start-stop button on the motor disconnect switch was in the stop position. The motor exhibited no evidence of arcing or electrical failure. So, with the start-stop in the stop position, it's unlikely that the ventilation motor presented the source of ignition at the time of the incident. What they're saying here is that the pressurized system was not operational. Now, was that the fault of the electrical contractor? Well, that's certainly something to be discussed at a later date with more information when they finally get to that point. But at this point, it appeared that it was the actual users of the facility which may have shut it down. What this caused was significant accumulation of dust inside the motor control center, which was not rated for that application. So if you have lots of dust accumulating in a non-HAZLOC enclosure, at a certain point, if you get a fault, you're going to have a much larger problem because it's going to ignite the dust. The conclusion was that likely the electrical ignition came from the equipment inside the MCC. There was a failure of a fuse or a piece of switchgear inside, and instead of it just being localized inside one of these cabinets, the explosion, the mini explosion inside, stirred up all the dust inside the MCC bay and caused a larger explosion inside the electrical room, which then ricocheted out into the adjoining larger sawmill area. The second fatality or explosion took place on April 23rd. This was at the Lakeland Mills Prince George sawmill. Again, 2 fatalities, 22 injuries. This one had a same sort of footprint of destruction we can see here. And these photos are all again taken from the investigation which took place after. We can see that everything has been ripped apart, and some of the photos here that I'm now showing are actually from an OHS inspection months prior. And so what you can see is that there's a significant lack of housekeeping that's occurred here, where there's monstrous accumulations of dust. How on earth that control panel could even have that much dust is beyond me. I'm guessing there must be a few open half-inch knockouts at the top that just allow dust to pour in. The end culprit for this particular explosion, they said, was likely due to the mechanical ignition from a cooling fan or on the belt-driven gearbox of an electric motor. So the cooling fan became loose, and it then came into contact with the protective shroud, which is also metal, and that caused sparking, which then ignited the dust which was around, and because there was so much dust, it was a catastrophic explosion. So, dust is dangerous. If we take a look at 18002 special terminology, we'll notice that the entry for dust is a generic term. There's combustible dust, conductive dust, non-conductive dust, and combustible flyings. These have to do with the type of material that the dust is made from and also how large they are. We'll also notice an entry for explosive dust atmosphere. It's a mixture with air under atmospheric conditions of flammable substances in the form of dust, fiber, or flyings that, after ignition, permit self-sustaining propagation, so they'll continue to burn. If we take a look at 18050 electrical equipment, we'll notice that for zones 20, 21, and 22, there are different group ratings for dust as opposed to gas. There are group 3 type materials, 3C, B, and A, which relate to combustible metal, combustible dust other than metal, and solid particles greater than 500 micrometers. 18050, Subrel 3, also indicates that for zones 20, 21, and 22, the maximum external surface temperature rating as marked on the equipment shall not exceed the lower of the dust cloud or dust layer ignition temperature determined for that particular location. So they're saying the surface of the equipment can't get that warm. And this is a tricky one to determine because sometimes equipment can have layers of dust on it, and that's not the error of the designer or electrician, it's due to poor housekeeping. 18068 indicates cable trays in dust atmospheres. Cable trays need to be installed to minimize the buildup of dust or fiber on them. And so that would mean instead of perhaps installing it horizontal, like this, you install it on a wall vertically, like this. And so there is less chance or less amount of material that would accumulate onto the cables. It's very difficult to remove dust from cables on a cable tray for operators at a plant. Zone 20, from special terminology, is a location which an explosive dust atmosphere in the form of cloud or dust and air is present continuously for long periods or frequently. If we take a look at 18190 equipment for Zone 20, we are sent to Table 18. And what you should notice from this is that it's extremely restrictive equipment which is permitted inside this particular area. We have all sorts of different types of HAZLOC which is permitted, and also notice that we can use older or the NEMA style of classification which they list here, Class 2 Div 1, in the same way that we were permitted to use NEMA in the gas environments. If we take a look at a equipment nameplate, we can see here often the equipment is rated with the class division system for use in dust environments, and many manufacturers will also ensure equipment is certified to both gas and dust. This is an example of a dust protected enclosure. It's really just a robust weatherproof enclosure or outdoor rated. It's got a special silicone seal around the door, and it's got a number of quarter turns around, not just one that holds it closed. 18192 is the wiring methods, and Subrel 1, item A and B is fairly restrictive and reminiscent of the gas atmospheres. That's tech and threaded rigid metal conduit. If we continue on, Subrels 2 and 3, cables are permitted and flexible conduit is permitted. Obviously, liquid tight for heavy duty rating and extra hard usage, flexible cable. Subrel 4, where flexible connections are subject to oil or other corrosive conditions, it says that you need to ensure that the conductors or the sheath is suitable for that. And so that simply means either the insulation is rated for the substance or the sheath. And it's because they're flexible. They don't want that oil to be getting onto the conductor's insulation and eating through it. Subrel 5, when wiring methods, where wiring methods for intrinsically safe, it says IA, installed as IA or intrinsically safe class 2 or 3 locations shall be permitted to be exempt from the requirements of Subrel 1. And so, generally speaking, what that means is that this cable here, the control cable, is not required to be HAZLOC rated, and it could be any different type of low voltage control cable that's specific for intrinsically safe, typically with a light blue insulation. 18194 is for sealing, and the sealing requirements are minimal in dust environments. Their one purpose is to prevent dust from traveling through electrical conduit systems when connecting a dust-protected enclosure to one that is not dust-protected. In addition, the physical layout of the conduit may act as an effective barrier against the propagation of dust. And so if we take a look at 18194, this is a rule that will be listed a few times from 20, 21, and 22 zones. So what it indicates is that there are actually three different options: A, B, or C. So A is a permanent and effective seal. So that would be like a flammable fluid migration seal. They don't even indicate what a seal would look like, but it certainly doesn't have to be explosion rated. B is a horizontal section of pipe 3 meters long. And C is a vertical section of raceway not less than 1.5 meters long if it extended down from a dust-tight enclosure. So you're kind of given these options here. And I've listed them all out to give you a cross-section of what would be required. Either the conduit is 3 meters or more. If it's less, then you got to put a seal. Either going down from the dust-protected enclosure, it's 1.5 meters or more. Otherwise, you need a seal. So there it is, 1.5 meters or more, and no seal required. So the sealing requirements are fairly lax, and it really is, we're not assuming there's an explosion inside the device. We're just trying to prevent dust from passing in one box down to another where it could cause charring. Zone 21, from our special terminology, is the same thing: explosive dust atmosphere in the form of cloud, of dust, or air, likely to occur in normal operation occasionally. If we go to 18200 equipment for zone 21, we go to table 18, and again there's a number of different types of equipment, and as you get further along with the zones from 20 down to 22, there becomes more and more and more equipment that is suitable. So here's a control enclosure rated for zone 21, very similar to what we saw for the TA enclosure for zone 20. Identical requirements are seen to zone 20 for the wiring methods and the sealing of conduits, so there's nothing new there. Finally, zone 22, which is the least hazardous dust location. If we take a look at special terminology, it is not likely to occur in normal operation, but if it did, it would persist for a short period only. So that means it's not really that hazardous. If we go to 18250, Zone 22 equipment, Table 18 provides an extensive list of what is permitted. Also, what we'll notice from 18250 is that in these particular situations, the chance of having an overhead crane is actually quite high, because these are areas where often we are storing or transporting materials which could be dusty or fibrous. And so if you're transporting or storing them, loading and offloading, often you have overhead cranes. So subrule 2 indicates that overhead cranes are going to operate over the length of the warehouse, and it makes the supply of power through the cables or conduit impossible over such long distances. So we're going to have exposed conductors or bus bars. The power supply to these overhead cranes is required to be ungrounded, and this ensures that an accidental ground fault of the power system will not ignite material in the vicinity. And so we need to have a ground fault indication system connected. Power is supplied through exposed energized bus bars, which run the length of the cable or the crane travel distance, and the crane then connects to them through a set of current collectors, much the same as an electric train. Now, the current collectors, as indicated in the rule, need to ensure that they have, I don't know, I think it says 2 conductive or current collectors per bus bar. This would be something that you would forward to the subcontracting company that's supplying the overhead crane, not really something you would be, as an electrician, determining when you install it. 18252 is the wiring methods for Zone 22. It's almost every single type of conduit or cable known to man. There is a lot of different types of conduit that are available and permitted, and really the only one I could see in there that isn't listed is EMT. Subrule 2 indicates that there's a lot of additional equipment you can install, like boxes and stuff, that are not HAZLOC rated. So if we look at Subrule 2, it says boxes and fittings where we have taps, joints, or terminal connections. shall be either an enclosure type 4 or 5, or, and it goes through a couple of descriptions here. So type 4 or 5 is like outdoor rated. So if it's outdoor rated, fantastic. That can be used, and you don't have to get a fancy HAZLOC box for the application. If you wanted to know what different types of box that are non-HAZLOC are rated, you go to 2400 subrule 1 or table 65. And finally, the requirements for sealing conduits in zone 22 is exactly the same as zone 20. So no point in repeating ourselves yet again.